All right, we are live. Here we go. Welcome back. Another episode of Building Stuff on AWS in my basement. This is Michael Walter coming to you for the eighth week. Yay, eighth week. Here we go. It's amazing. I was actually thinking of skipping this week, and then I changed my mind because why not? We got to do it. We got to keep doing it. Got to keep on keeping on. So yeah, I got a lot of stuff to talk about today. I feel like last week we kind of got off the rails a little bit with DynamoDB. So I've done a little bit of homework on my side to try to explain DynamoDB a little bit better. And what I really want to do today is get to the point where the thing that we've been building for weeks, it seems like, is in a good place, and we can kind of start thinking about turning it into something actually useful to start building something on top of it. So I have a lot of ideas. I'm going to try to just sort of go through them with you today. We'll see how it goes. But let me get a few things going here. Let me just share my screen. I want to do a little bit of a quick recap as usual. So hang on, let's do this. Oh yeah, that's okay. Yeah, as usual. Let's start. Let's start with this. So, and let me bring myself over here. Okay, cool. Actually, you know what? I think it looks better. Yeah, it doesn't really matter. Like this. Yeah, like that. Okay, I'll be on the left this time. Cool. So this is our architecture we've been working on for a few weeks now. Seems like more. Maybe it's been a month. I don't know. We've been working on this for a while. Uh, so I really want to get this wrapped up. And so let's first of all let's clean this thing up because I feel like I keep saying we're going to get to this, and we never do. So let's just get rid of some of these things. Let's clean this guy up a little bit so we can have a good discussion about it. But anyway, this is what we're building. It's a really simple service, which basically is meant to generate poems inspired by artwork of the Cleveland Museum of Art and their open access collection. So we're using API Gateway, we're using Lambda, we're making an API call to the Cleveland Museum of Art's open access API. We are using that response to generate poems using Amazon Bedrock. And we're currently using Anthropic Claude Haiku, Claude version 3 Haiku, which came out about a week ago or two. And we're storing stuff in DynamoDB. And the whole idea here is that the Lambda function first looks in DynamoDB to see if we have already generated a poem. And then if we haven't, we go through this flow of generating a new one and storing it in DynamoDB before sending it back to API Gateway. So that's our project pretty much as it is. It's pretty simple. And last time we got a little tripped up, I think, or I got a little tripped up, I think, kind of trying to make some more functionality in terms of talking to DynamoDB. So I thought like today, what would be fun would be to just kind of like, I don't know, do kind of an overview of DynamoDB because, I'm trying to make this for people who are new to serverless, new to AWS. And DynamoDB is a cool thing. It's a really interesting service. And it's one of those things that's just there waiting for you to use it. And you don't have to provision anything. It's completely serverless. And it does a lot under the hood. There's all sorts of bells and whistles and knobs and levers to play with. So yeah, I thought I'd spend a little bit of time talking today about DynamoDB in general. And then maybe we can try to get back into the code and make some of the things work that weren't working last time. Short story is I went back after the show last week and fixed a few things in that SAM template. So that's all working. The thing's deployed now properly. So hopefully we won't have those kinds of issues today. But yeah, I think, yeah, let's get into DynamoDB and then we can kind of go from there. So here I am in the AWS console. This is DynamoDB. So if you've never seen it before, this is what you get when you go over to DynamoDB. So let's just talk about it like in real high level, like what is DynamoDB? So It's a completely serverless database, and it's a NoSQL style of database. So different than MySQL or Postgres, it's not a relational database. It's a NoSQL database. So that means it supports kind of like a key value style of storing data, or document style style of storing data. So what I think is super cool about DynamoDB is that there's literally nothing to provision. And this is the thing that kind of confused me when I first saw it years ago, is that you just go to DynamoDB and it's like there, ready to rock and roll. There's no servers, there's no like nothing. It's just ready. So the thing is, there's no database to kind of start with. It's just tables. So in most, like if you've ever provisioned a database on in the cloud, you always start with like let's create a database. You don't have to do that in DynamoDB. It's ready to go right away. And what you wind up doing is creating tables. So you can create as many tables as you want. And tables are where you kind of configure how you want the service to be. So rather than configuring things at the DynamoDB or the database level, you configure everything at the table level. And that's super cool because you can kind of configure each table, you know, depending on its unique characteristics or its unique set of requirements. But let's take a look. Let's take a look at what I mean. We have our table here that we've created from the poem generator project, so we can use that as kind of a way to kind of explore DynamoDB. And so in DynamoDB, there's kind of four major things to think about. So you don't have to think about the database itself, like I just sort of went over. There's tables, and then so let's go into a table. Here's one of our tables. It's called Go Generate Poems, and then a bunch of characters, because I created this with Sam. But in any case, there are tables, and within tables, you have items. And items are like rows in your relational database. So they're each record in a DynamoDB table is called an item. Then each item will have attributes, and attributes are kind of like the columns in a database, sort of. So attributes define the different aspects of a particular item. And then lastly, there's indexes, and indexes are what allow you to look things up in DynamoDB. And so this is where things get a little bit confusing for people, I feel. So let me talk about indexes for the moment. So first of all, when you create a table in DynamoDB, actually, you know what? Let's do that. Let's create a new table. So they're going to ask you a few questions here when you create a new table. And this is just in the console. Like if you're doing this through SAM or programmatically, it's the same, basically the same thing, but this is very easy to see this way. So you create a table, you have to give it a unique name. So let's just call this like test table. You can use underscores, doesn't matter. So test table. And then it's going to ask you for two things, and these are very important. So it's going to ask you for what's known as the partition key, and then the sort key. And the sort key is optional. So if you want, you can just have a partition key, and a partition key is basically the identifier that you'll use to look things up in your DynamoDB table. So oftentimes, a partition key will be something like an ID. Right, so if you have a table of users, each user might have an ID number, and that allows you to look things up by that ID. So you put in what you want the partition key to be called, and you give it a data type. And data types in DynamoDB are really straightforward. There are three of them. There is a string, a number, or a binary data type. So you set that. So let's do that. Let's make an ID, and we'll use a number for ID. The sort key is an optional part of an overall key. So it works in combination with a partition key, and it allows you to create a uniqueness, right? So if your IDs in this particular table are not unique, right? Like let's say this table is a Like let's say we're building like a CRM or like an ordering service or something like that. And so we have a table of users, and each user has an ID, but then we have a table of orders. Uh, let's say orders or some or products. Let's say products, and they each have an ID, but the IDs you might have multiple records of the same ID. In any case, the point is here you need some way to create some more uniqueness. So you might add like another ID that in combination with this key creates that unique kind of overall what's called a composite key. So very often the sort key is something like a date because you can also do things like doing a query over a range. So like give me all the records that are newer than yesterday or something like that. But it doesn't have to be. It doesn't have to be a date. It can be anything you want it to be. But they work together to create this idea of like a composite key. And so what's kind of confusing to me when I first started looking at DynamoDB is that there's this thing called a partition key, which is the abbreviation is PK, and then there is the primary key, right? And so primary key is kind of like this thing together or this thing on its own. It's also PK, so it's a little confusing. So don't get tripped up on that at first if you're learning about DynamoDB. In any case, every table has to have at least a partition key and optionally a sort key. And you have to decide this when you're creating the table. You can't change it later. All right, so then there are some other settings. And so in DynamoDB's kind of console experience, you can either use the default settings or you can go through and customize each one of these. And it'll tell you right here which ones of these you can change later. And the one you can't change is local secondary indexes. And I'm going to go through what these things are in a moment. But pay special attention here because when you create a table in the console, the default settings are going to have provisioned read and write capacity. And so that's an interesting thing about DynamoDB is you have two ways of dealing with capacity. It's basically two different ways to pay for DynamoDB. One is on demand, which means you pay as you go. So every request you make to DynamoDB, it'll calculate out how much read and write capacity it wants you to use. It'll scale things up and down if depending on the load attached to it. Or you can use provisioned read and write capacity. And so if you have an idea of what your load is going to look like, in production or something like that, and you can measure this, you can kind of put in values that you think you'll nominally be around, and it's a little bit less expensive to do it that way. So the default is 5 RCUs and 5 WCUs, and so this is good for like a lightweight application, kind of getting started. But if you're really just testing and developing something, and you're going to make a table and kind of leave it as is for a while, I recommend switching this over to provisioned mode. I'm sorry, on-demand mode. So you won't be paying for those compute units while you're not working on the project, basically. In any case, so that's something to know about. And so then you'll see there are these different kinds of indexes. So this is another important thing. This is kind of what we got tripped up on last time a little bit, and I'll explain why when we get there today. But there are two kinds of secondary indexes. And so in addition to this partition key that you've created, you can kind of think of this as your primary index or your primary key. This is the thing that you can look up records by. You can create more. And so there are two kinds. Is what's known as a local index and a global index. The local index basically gives you a second uh, sort key, I think. I have to double check that. It's one or the other, but basically it works with an existing partition key, I believe. That's how it works. So let's say you have a partition key set up with date as your sort key. Let's use that number as well. That's nice. You have an ID and a date as your partition key and sort key. But you also want to be able to look up things by the ID and some other date, like I don't know, modified date or something like that. You could create a local index and have essentially a different sort key. So this could be like created date, and your secondary index, for example, could be like modified date. So just some ideas. And that would still use the same primary key, or sorry, partition key. So that's a way to add more sort keys, basically. Secondarily or optionally to that, you can create a global index. And so a global secondary index, or a GSI, allows you to create another index based on a completely arbitrary partition key. So you can have a completely different way of looking up items in your table. And so that's what we were doing, or at least we were trying to do last time, was to create a global secondary index that allows us to look up items by that accession number field that we were talking about last time. Cool. So, for example, you could go here and say, yeah, you basically create a secondary sort key. It'll use the same partition key as the base table, so with a different sort key. And then each index that you create, each local secondary index or global secondary index, will also have its own index names. And then there's some options around projections, and this is which attributes within each table are copied into that secondary index. So there's a couple options there. Anyways, there's a bunch of other stuff here you can play with around encryption, depending on how you want to encrypt your data, deletion protection. Some of these are all by default turned on or off, so you can kind of look at the defaults there. Different policies and tags and all that kind of stuff, and that's basically it. But let me go back to tables. Yes, I want to leave here. There's a couple other things that I think are really worth exploring in DynamoDB. So here's this table we created last time for generating poems, and you can see we currently only have one poem saved in there at the moment, which is fine. And I can click this button to explore table items. And if I go down here, I can see there's my single item. You can click on it. Actually, you can even edit it right in here if you want to. But you can see the different attributes. So there's an ID, which is my partition key. I don't have a sort key for this particular table. And then I have two more attributes. I have an accession number attribute and the poem itself attribute. And so these are all strings. And what's cool about DynamoDB is you can add more attributes. So it's sort of dynamic in that way, where you don't have to figure out this exact schema right out of the gate. You can add more attributes later on. There's nested JSON, all sorts of stuff you can kind of mess around with. Pretty cool. You can nest attributes inside of other attributes up to 32 levels deep. It's amazing. Okay, so let's go back here. I want to show you a couple other things. And so what's nice about the console experience is that you can actually query your data right here in a couple of different ways. And so you can query, and we can query this table. And you can put in the ID, so we know our ID. Right, so I can click that and paste in my ID, and I can add filters. So I can. It's a little silly because I only have one item, so there's really nothing to filter. But you get the idea. I can run that, and I can actually see the record come back, and I can see how many read capacity units were consumed, which was 0.5. But then also take a look here. I can also query not just that table, but I can query that global secondary index that I created last time. So I actually after the session last time, I went through and got this working. And so that lets me query by accession number. And so I can put in my accession number, still has the same filtering available, and I can run that. And I get the same result in this scenario because I have only one record, but you get the idea. I can now query by both the ID or the accession number. And because I have that secondary index, I'm able to do either one. Cool. Scanning is another way of querying, more or less, but basically it's a little bit less efficient. It does let you look for stuff over other fields. So, like, I wonder if I look for the word tranquil. Let's see. Let's try this. So, I'm going to scan my table. Uh, no, I guess I can't do that in this. Yeah, it's not really a filter. So if I do, okay, so if I do run the scan, so scanning, it basically scans the entire table. And so in this scenario, I have no filters. So I'm going to get back everything, which is just that one record. But if I put in like ID is equal to 0, I should get back nothing, right? Exactly. So you can scan, but like again, like you can't scan over. It's quite a bit less efficient to do it this way. So that's why the global secondary index option is very nice. Cool. Let's see. I want to show you a couple other things. So there's a few other things about DynamoDB that are pretty interesting. One of those is streams. Uh, so, well, yes, you can export your data to S3, which is nice. You can also back up your data very easily here. But there's this feature here called streams. So there's a couple different kinds of streams, but the one that I really want to talk about is what are known as DynamoDB streams. And what this does, it allows you to create events that get fired basically every time you do something in your database. So whenever there are changes to the data in your database, or like a new record or a deletion or whatever, you can have DynamoDB fire off an event which you can consume with a Lambda function. So you can have a Lambda function basically polling your DynamoDB stream to look for changes. And this is a great way to create like an event-driven architecture around this table. So, for example, like let's say every time I added an item to this table, like a new poem, I want to send me a text message. uh, I wouldn't do that because I would probably get a lot of text messages all of a sudden. But that's you could totally do that. You can create a architecture that will react to those new items in the table. So that's super cool. So that's another thing to know about. All kinds of uses for that. All right, great. So that's DynamoDB. Like I said, there's a lot more to it than what I just described. There's all sorts of settings around auto scaling or TTL, so you can automatically delete items after a certain date, that kind of thing. So this is a great way to kind of deal with stale data. So like in our scenario, in our architecture, if we wanted to, for example, once a poem has been there for a month, we want a new one generated. Super easy to do with DynamoDB. We could just set a TTL of 1 month, and then after a month, those items would get deleted, and then whenever a new request comes in for that same item, it would generate a new one rather than just serving it from the database. So that's kind of cool too. Yeah, there's a bunch of other options here. So that's kind of the quick tour of DynamoDB. All right. So um, what I want to do now, I think, is basically get DynamoDB to do the things we were trying to get it to do last time. So let's jump into code editor, and I'll hang on a sec. Here it is. All right, there we are, code editor. Let me go over here. There we go. That's not bad. All right, let me fix this a little bit, make it a little bit bigger. A little wider. There we go. All right, and then it's a little small, so let's make it a little bigger. That's too big. That's nice. Okay, there we go. Okay, so we're back in VS Code. And by the way, I put this code repository on GitHub, so you can check that out. I'll share the link uh, on YouTube once we finish up the stream. But basically, yeah, everything we're doing here is going to be up on GitHub periodically. So first of all, let's talk about SAM. So that's the thing that kind of tripped me up a little bit last week. Um, so when you're creating a table in SAM, here it is. Here's our table in SAM. Uh, so the first part of it, you have a type DynamoDB table, and then you define a bunch of properties. And so you only really need to define the partition key and a secondary key if you have one, or sort key rather if you have one, and then any secondary keys or indexes here, sorry, secondary indexes get defined separately. So let's walk through this. So there is an attribute here called ID. It is a string. There's also an attribute called accession number, which is also a string. Notice I don't have the attribute for the poem itself. You don't need to have that. It'll just create it when you put a record in. But these have to be here because these have to do with our indexes. So we have these two attributes, and then we have this key schema. And so this is for the primary key. Our primary key is our ID, and it's a hash type of an ID, or a type of a key. If I wanted to have a sort key, uh, additionally here, I would have to add that here as well, but I'm not doing that. So if I wanted to add like a created date or something like that, I would create the attribute up here, and then add another attribute here as part of my key schema to define that sort key, and it would say range instead of hash. So it's a little confusing. It took me a while to kind of figure this out, but that's how it works. Then to create a global secondary index, you actually have a whole nother section here called global secondary indexes. So you can make multiple ones. And so here I've made one called accession number index. That's the index name. And then it has a key schema. So its key schema is the accession number instead of the ID as a hash. And then you put the projection here as well, which we're just going to project everything for now. So again, if I had a sort key as part of my secondary index, I would define that here as well. So anyway, so this is how it would look. Yeah, it took me a little while to kind of understand this because it's a little confusing. They're all like named attribute something keys. It's kind of, yeah, it's not easy to follow in this template, but once you figure it out, it's pretty simple to set it up. And you only have to do this once. So once you've created this structure here and deployed it, you should be good to go. Okay, so let's get into the code now. So yeah, here we are. Okay. So this is our main Go function we're still working with. And let's start down here in the handler. So again, this is a Lambda function that does all the things, right? So let's walk through what it does real quick. And then we'll start to build out some stuff that we didn't do last time. So yeah, first of all, it grabs an ID, and it grabs this ID from our query string parameters. And the whole point of this exercise here is that we can either pass it an actual ID number, like a 1, 2, 3, 4, or we should be also able to pass it an accession number. And we'll need some code to kind of like make sure that we understand which one is which. Or actually, rather, we've already done that. I'll bring that up in a moment just to kind of review that. So the point is, it doesn't care. It's going to grab that ID, and then what we're going to do is we're going to try to check if we already have that in the database, and that's the part we're going to need to work on today, because we can't currently get. If we pass it an accession number, it's going to be like, "What are you doing?" Because it's expecting an ID. So it's going to send us back like a 404, basically. Okay, so once we decide we don't have, so if we don't have a poem, let's see here. So if we do have a poem, we just return it to API Gateway. So basically, the poem ID is not empty. We already have a poem. Let's return it back to API Gateway with a 200 status code. That should end the function, right? But if we don't have a poem, if this doesn't happen, we're going to move on. So what we're going to do is we are going to grab an artwork from Cleveland Museum of Art. We're going to get it, by ID. So we might have to fix that up in a little bit. We'll come back to that in a few. And then we're going to craft our poem using the JSON that comes back from that API call. And we're going to send that as our prompt to Amazon Bedrock. That's going to generate our poem and send it back to us. Once we have our poem generated, we are going to add it to this struct so that we can save it into DynamoDB. And you can see I've added the accession number field here, or attribute, to our struct. So I'll show you that in a moment too. So then we do this put poem bit. So we're going to put our poem into DynamoDB. And then we are going to return the poem itself back to API Gateway so that our client who's sitting there waiting for a poem gets what they asked for. And that's basically it. That's the whole handler at the moment. So yeah, so let's take a look first of all at this put poem function, because I did change that a bit so it does work to add our accession number. So if we look at, let's see, where is it? Up here. Put poem was pretty simple. So nothing really changes except I add this line here to put the poem's accession number in there. Okay, so it just pulls in that attribute or that field from the struct and saves it as this attribute here called accession number. And so that means I also had to add accession number to the struct up here. And so if you remember when we first created this, this is where you define in Go the fields that you want to save to DynamoDB. And you do that by, you give it kind of a name in Go on the left-hand side. And then on the right-hand side, you tell it what you want it to be called in DynamoDB. So the only difference here is that they're like lowercased with the underscore kind of notation. But that's it. Okay, so let me bring up something. Just a sec. Let me just see. Oh, yeah. Just want to take a look at the Cleveland Museum of Art code. I think, just trying to remember where I did this thing. Okay, I didn't do it. That's okay. No, that makes sense actually. Okay, here's the deal. Here's what I was just looking up the code here. So let's go down to here. So in the handler, the first thing we do is we grab this ID. Okay, so we don't know what this thing is. We don't know if it's an actual ID number or an accession number. Now, the difference between an ID number and an accession number is pretty simple. One of them is an integer, and the other one's a string, right? And so we can write some code that will easily tell us which one of those things it is. And then what we can do is we can kind of behave a little bit differently depending on which one's which. So I don't think we'll need to do it here. Yeah, so we want to do it in the getPoem function. So we're just going to grab whatever. We're going to grab whatever is passed in as an ID, and then we're going to pass it to getPoem function. So let's take a look at what getPoem looks like at the moment. Here it is. Okay. Yes. Okay. So here's where we want to make some changes. So right now, what we're doing is let me just talk through this function. So we pass in an ID. It comes in as a string. That's fine. And we're going to return a poem struct and an error. So the first thing we do is we set up our connection to AWS. That's all good. We create a service for DynamoDB. We set up the poems table name. So that comes from our environment variable, which we can do here in a moment. And then we try to get that poem by its ID. And so here's where it's a little bit interesting. So if all I want to do is look up an item by its primary key or its partition key, it's really easy to do. I can use get item from DynamoDB, and I can pass it that ID right there. Okay, because I know the ID, so I should be able to just do that. This function will work, and it does work. We've been doing this for a while. If we want to actually look up an item in DynamoDB by a global secondary index, which is what's currently the way that we're going to look up by accession number, we can't use get item. Get item doesn't really apply. We have to actually do a query. So what we want to do here is we want to create a conditional statement that says if we have an integer, do it this way. If we have a string, which would be the accession number, do a query. So first things first, we need to know if we have a integer or a string. So let's see, how can we do that? So I did have some notes for doing this last time. It's really simple, but I don't know if I saved it. Let's see. Bear with me for a sec. I did not save it, of course. There's a function called A2I. So let me just Google it real quick. Here it is. I did this last week too. So I have here it is. Check if it's a string or an int. Yeah, here it is. Okay, so it's a really easy, I just forgot what it is. Let me just type this in here. So this function, okay, so let me talk you through this. So here's a conditional if, and there's a core package in Go called string convert or strconv, and there's a function here called A2I, and I believe it stands for ASCII to integer. And basically, what we're saying is like, let's given me an ID or some variable. It has to be a string. So given a string, if I convert the ASCII characters in that string to an integer, and it works, then it's an integer. If it doesn't work, if it fails, it must be a string. Like it must be a string, not an integer. Okay, so let me type out what that means because that's very confusing. So my ID, if my ID looks like this, right? That can be an integer like that, or we can put it in quotes and it's a string, right? But what if my ID looks like, hey, look at that, Code Whisperer already knows what I'm doing. A, B, C, D, E, 1, 2, 3, 4, 5, right? So this thing you could easily convert to an integer, right? You can just basically say, what's the integer equivalent of this string? And it should be 1, 2, 3, 4, 5. But there is no integer equivalent of this. This thing actually is just a string. So this is what we're doing here. We are using the A2I function within string convert to test. All right, so we're going to test if what we're passing at the ID here is a integer or a string. Amazing. All right, let me just fix this. All right, cool. Okay, so instead of just printing out looks like a number, what we're going to do is, let's say, let's do this. Accession number. Let's do, all right, var accession number string. Nope. What am I trying to say here? Var string accession number. What am I doing? I'm doing it backwards is the problem. Okay, var accession number string, I always forget the order. Okay, so it's not, red means it's not being used yet. Yeah, okay. So I'm just going to declare this variable called accession number. The default value when I declare a variable, a string variable like this, is an empty string, right? So this is currently an empty string. And so what I'm going to do is if, well, let's just do it the other way around here. Yeah, let's do a not equals nil. I don't need this line anymore. I can do accession number equals ID. And then I'm going to use it somewhere else, so it's not still considered not being used, but that's fine. Okay, so let me explain what I'm doing. So what I'm doing is I'm still doing the same test to see if my ID converts to a string or not. But what I'm doing differently here is I'm saying if it doesn't convert to a string, or sorry, if it doesn't convert to an integer, set the accession number variable to it, right, to the ID. And so now I have an accession number with some value in it. And so that can tell me later on here what I want to do. Okay, so what I want to do is create a condition here. So I want to say if accession number doesn't equal empty, I want to do it one way. Else do it this way. Okay, so what does that mean? So that's saying if our accession number actually has a value, we are going to query the database on its global secondary index. Otherwise, we are going to do what we already do. So let me just copy this out and stick it in here. And let me just tab it over a little bit. And then here is where it gets interesting. We want to basically we want to use the query function. So let me look up how to do this real quick. All right. So I think the difference is it's going to give us back an array, I think. So let me just make sure I have this correct. Actually, I'm just going to type it out because it's pretty straightforward. Okay, so let's, instead of poem, okay, I'm just thinking out loud here. All right, so let's do var poem. Yeah, that'll help that. And then we don't need one of those. Okay, so I just, because it's inside of a else statement, we have to define this poem up here because it's scoped inside this if else statement. So this just allows us to save it and use it later, basically. When we want to query using that accession number, we're not going to get back this same thing, DynamoDB get item output. We are going to get back something a little bit differently. So let's just start typing. So data. Look at that! It already knows. Code Whisperer just knows. It understands me. It gets me. Look at this go. Okay, this is great. I'm just going to keep tabbing and yes, that's what I want. This part, I don't know what this part is going to be. Oh, these are the attributes I want to get back. Yep, yep. Nope. I think that's it. I think, unless, do I need a key? I already did that one. All right, this is like slightly correct, slightly, got a couple problems, but we'll fix it here in a moment. All right. Oh, and then I need a closing thing there. All right, let's see what this did. So this is, I mean, it's pretty close, to be honest. All right, so this is, okay, so what we're doing is we're doing a query instead of a get item. And we have to populate this query input struct. And so we need a table name. We already have that. Attributes to get. I didn't see that pop up, so we'll come back to that. That's kind of interesting. Conditional operator. Can you guys see this little pop up? I don't know if you can see. Oh yeah, you can. Cool. All right. So if we want to put conditions in, that's we don't need to worry about that. Consistent reads. Okay, keep going. Expression attributes. I don't think we need this either. Interesting. Okay. Filters, no. Index name we do need. Yes. So what did we make the index name? Accession number index. All right. So just to keep moving, I'm going to hard code that thing here. So index name should actually be accession number index. Oh, yeah. Okay, so this is kind of one of those funny things in Go. So we need a oops. Let's do this. Index name. And then we'll put here, it needs to be a pointer. Okay, so that works. I want to talk about pointers eventually here, but for now, it's not actually a pointer. It's dereferencing. It's pointing to the blah, blah, blah memory area. All right, key condition expression. I don't know if I actually need this part. Let me just look at some notes here. Expression names. Oh, yes, let's see. Expression names. Okay, so I'm gonna copy and paste a couple things from my notes over here because this will make it easier. Expression. Oh yeah, that's a DynamoDB. That should load in here. Let's see if that works. No, okay. So let me add this. All right, so we're going to do a go get, and then we're going to add expression. I think that worked. Let's see. Hold on, bear with me. Oh, it's a feature. I had the wrong one. My bad. It's not a service, it's a feature. Go get this thing. Okay, now, there it goes. Okay, now it's working. Okay, so, all right, so we're basically creating an expression attribute thing here. Global secondary index primary key, or partition key. I think that's what that means. All right, we're going to just sort of try and see if this does something what we want to do. Now this expression attributes thing, All right, so anyways, this is wrong. Let me just fix this real quick. Uh, Hold on. No, wait a minute. Where'd it go? Here it is. Okay. Um, Let me delete part of this here. Okay, so what we want to do first is expression attribute names. And that is going to be expression.names. That's correct. Okay. And then expression attribute values. Same thing, expression.values. All right. Key condition expression is the filter. Oops. Key condition expression is no. Expression.filter. Whoops. Okay. I think that's all we need. Well, we need to check the error. So that is just a if error is not equal to nil. This is exactly the same error we're going to do here. Oops. Okay. Okay. Cool. So I think this is going to work. And what have we done? We've created a condition statement here. So basically, we're saying if we do have an accession number, if it's not empty, we're going to do this business where we're going to query DynamoDB using the global secondary index. Yeah. Is that table? Yeah, that's correct. Okay. Let's make that a little neater. Instead of index name, we're just going to make it index. Just so it's nice and neat. Okay. Otherwise, if we don't, we're doing this, what we were doing before, which is using the get item thing. Okay. But that doesn't make any sense because we're not. As expression value, one of these things has to be the accession number. My copy and pasting is not helping here. So let me just look up what this would be. Global secondary index, yeah, okay. Oh, I see. Sort of. All right, let me just look this up real quick. What? I'm losing my mind here. Something's not right. I'm missing something here. All right, so I know what I'm missing. All right, so expression name creates a name builder. The argument should represent the desired item attribute. Yeah, okay. It is possible to reference nested items. Oh, okay. So this should be accession number. And this should be the value, which is the accession number itself. I think that actually makes sense now. Okay, but I see there's one other problem here. So this is going to give me a query output, and this gives me a get item output. And so the problem is I'm trying to marshal the response from either of those things. Okay, so I have to marshal it separately too. Because ultimately what I want is this thing called a poem. Okay, so what I have to do, okay, I know what to do. I need to move this up above this whole business here. You know what? Let's put it right by here. And then the same thing, I need to make a data query output. And then here, that should be like that. Okay. So basically, here's what I need to do. I need to either marshal my poem or I need to marshal my data. Ultimately, it has to wind up being an item. Okay, fair enough. So what I need to do, first of all, this one we know how to do. This one, all we need to do is use this unmarshal map, but I need to do it right here. Okay, and then I need to figure out how to unmarshal this thing. So let me figure out how to do that. It's a list of maps. So it's like an array of maps, basically, more or less. Okay, so instead of using the unmarshal map, I have to use unmarshal list of maps. I'm gonna explain all this in a minute. Okay. So I don't want to actually return I'll come back to this in a sec. Items. Okay. You know what? I think I know how to do this. I'm just going to take a guess. I think if I do items and make it an array of poems, this actually just might work. But I don't want to return it right here. I want to return nil. I want to make this a little prettier. I want to say error unmarshalling poems from the database. Yeah, okay. But here's the deal. In this case, I get back items. In this case, I get back item, but I only want one. I don't want the whole array. Okay. So what I can do is I can, in here, I can just take the first one. So I can say item equals item 0, assuming I'm always going to get, oh, yeah, I'm always looking for, oh, what's up with this? Error string should not end with punctuation. Oh, yeah, fair enough. I agree. Or new lines. Yes, I also agree with that. Okay. Whew, okay, I think this might be working code now. Maybe. What's this? The value of error is never used. Oh yeah. You know what? That's fine for now. So okay, so you just noticed I put in a little underbar underscore in place of my error variable there. So that's a cool thing in Go to know about. If you don't care about the return value of a function, especially when there's multiple return values, you can substitute this underbar underscore character, and it will just basically pretend like it didn't happen. All right, so let's move on. So I think I think this is working code now. So let's try some stuff out. I'm I'm thinking whether or not it's completely working code. I don't know, but let's see what it does. So let's do a SAM build. I'm going to be really surprised if this actually does anything because, yeah, we've been doing a lot of coding and haven't really run anything yet in a long time. It's been an hour. We haven't run code yet. So very, very likely this will not work. So I'm going to do SAM local start API. Oh, you know what I need to do? I need to set up our environment variable. And nope, and you know what? It's going to be a different name now. Why am I doing this ridiculous way to do this? Okay. It's not, okay, let's just do it from scratch. Okay. Export, what did we call it? Poems table name. Oops, poems table name equals, I have to grab this from DynamoDB. Okay. There it is. Okay, now we can do SAM local start API. Interesting that worked. Oh yeah, okay. I'm really like debating myself here whether or not things are going to work. So let's do this. Okay. So Perl. Let's try ID equals 0. So we should get back an error. Okay, so it's Docker is doing its stuff here, so that's why it's taking it. All right, internal server error, fine, that sounds good. Yeah, let's try it again actually, because I think it was doing something funny. Okay, so that's an expected result. Error could not fetch data 404. There is no record 0. Okay, that's good. All right, so let's do one that we know exists. First of all, let's test our by ID. Let me grab the ID that we have here. Okay, so whoops. I'm over on, okay. What I'm doing right now that you can't see is I'm just trying to grab the ID that I have in DynamoDB. All right, I have it here. Okay, so let's, instead of 0, now we're going to curl this guy. So this should give us back a poem. And there it is. Okay, that worked. That's good. So now, a moment of truth. Let's see if we can do it by accession number. So the corresponding accession number is this 1998.78.14, which is clearly a string. So it should, let's see if it does anything. Oh my goodness, it worked. Look at that. I can't believe it worked. So look, we passed it a accession number instead of an ID. What did it do? It did a bunch of stuff. First of all, it ran this get poem function. It figured out if that thing is an ID, an integer or a string. And because it was a string, it did our query on our global secondary index with all this code that I'm still pretty uncomfortable with, obviously. But look, it basically looked up in our global secondary index using accession number as the attribute name and the string accession number that we passed it as its value. It ran the query, and we popped off the first item in the array that came back. And that's it. And then we returned that back to the rest of our program, and everything else seemed to work, which is really surprising, in my opinion, because we've been coding for so long without doing any testing, which is not ideal. uh, but yeah, we lucked out. Okay, cool, amazing. Um, let me see if we have anything else we have to do here for that. So I think, all right, I think actually it might all be good. So, okay, well, let's do this. Let's test. Let's start our local API back up. Let's test what happens if we create a new one that I know is going to be there. So let me just grab an ID while that's spinning up. I'm blown away. I can't believe it worked. Okay, let me grab a different ID that we haven't done yet. Ooh, let's do it by accession number, actually. Okay. Okay, so that's running. Let's just test the last one we did and make sure it works. Again, still working. All right, so let's try one we haven't done yet, but this time we are going to do it by accession number. So that's a real accession number. So that should work. Let's see what happens. Okay. Cross your fingers. Internal server error. Okay, wonderful. So there, yeah, what did I do wrong? Calling the handler function which resulted in a panic. Something even worse happened. Okay, what happened? Index out of range error. Okay, that's lovely. All right, let's walk through what happened. Okay, so what we try to do in this case is we passed it an accession number that it doesn't recognize. So it must have done this get poem. Oh, I know exactly what this is. Well, I think I do. If we do a get poem, and what we did in our get poem function is we looked it up by accession number. It came back with, and I tried to do this. I'm guessing that's the error, right? So this is line 119. I already threw out that log, didn't I? Yeah. Okay, well, anyway, do I have any? Okay, so, okay, what happened was I tried to query this accession number, and it does, um, hmm, I see. Okay, so what it did was it tried to get this from from DynamoDB, and there is no result. So it would have come back with, I'm guessing, an empty set. So items is an empty set, and I tried to copy over items 0 onto item, but it doesn't exist. So what I need to do is test for that first before I just pass back. So work in this old version here, prior to today, it's fine because I'm returning basically an empty item, like a single empty item. But here, I'm trying to do the same thing, but first I'm trying to copy it from a slice of items that doesn't exist. So what I need to do before I do that, uh, actually, all I need to do is, look at that, if length of items is equal to 0, if length of items should be greater than 0, do that. Will that work? All right, let me think about this. So if what we're doing is we're saying if the length of items is more than one or more than zero, uh, copy it onto item, copy the zero element onto item. If it's not, we don't care. We're just going to move on, and we're going to do as usual. We're going to return an empty item back to the code. So let's see if that fixes it. Okay, let me just make this bigger. Okay. So first of all, let us build it. Okay, so now let's start the local API. Okay, so far so good. Let's make another terminal. And we're going to try again. All right, so we're curling this 1953.424 object. Oh, because I closed my terminal. So silly. Yeah, so let me, because I exited out of my terminal, my table name is lost. So let me just do that again. Local start API. I don't love working locally like this, but and I think maybe next week or sometime soon I'll show you how you can kind of work in the cloud as you go. Anyways, because we're kind of like half in the cloud right now. We're working with a DynamoDB table in the cloud, but we're running locally. All right, so let's see if this works. Hey, look at this. It worked. I can't believe it. It created a new poem, and it used the accession number. Now let's flip over to uh, web browser and take a look at what we made. So let me share my web browser. This one. All right, this is what we just made. But let's look at DynamoDB. So now if I run this, it's, there's a bug, but it worked. So it saved that poem um, as a new record. It saved our accession number, but look at this. It saved the ID also as the accession number. That's not right. So there's a bug, but it did work. It did save, and it generated a new poem and saved it. And we did that by passing it an accession number and not an ID. So that's kind of cool, but it's also kind of wrong. And I'll show you. I think I have a hunch as to why. So first of all, let's delete that item. All right, and let's jump over back into code. We're going to get this right. We're going to be done with this real soon, I hope. Okay, so back to code editor. Okay, so what happened? We managed to save a new, so in our put, all right, here's put poem. We're passing it poem.id, poem.accession number, and poem.poem. So why is poem ID coming up as the accession number? That doesn't make sense, does it? So let's see, what did we do? All right, so we're setting our poem. Okay, so first of all, back up a little bit. Down here in our handler, we're setting ID to ID. So p.id right here equals ID. And I think, aha, and our ID is a accession number because that's what we passed it, right? So what we need to do differently, rather than putting in the ID, see how we have this art.accession number? This should be the same thing. It should be art.id. Right? What am I forgetting? Oh, is that right? Hold on. Um, there it is. Lowercase id. That should be fine. Why don't I have it? Let's see. Oh, because it's an integer, and we want it to be a string. Oh, no wonder. Okay. So we're just going to cast it to a string like that real quick. And that, oh, I can't do it though. I have to do a sprint x. Okay. Yes, that's exactly what I meant. Thank you. Oops. I think just sprint. Is that right? Let me just double check this. Actually, I think that's correct. Okay, so I have an integer called art.id. I want it to be a string. I'm using this sprint function to format it into a string. I think that will work. All right, let's just we have we have some time here. All right, so let's build it again. Let's try it. And let's see what happens. All right, so I did a SAM build. Now I'm going to do the same. Wait, do I already have that running? Yeah, all right, my bad. So let's do this all over again. All right, SAM build. Cool, and let's do a SAM local start API. All right, that's running. Now we're going to do the same thing. All right, so 1953.424. Okay, that seems to have worked. Let's go check our DynamoDB table now. Once we're done with this, we're going to have a little talk. Oh, I did the wrong one. Okay, there you are. All right. So let's take a look at our database now. Okay, it worked. Look at that. So now we have 2 records, 2 poems, 2 IDs, 2 accession numbers. I think we're doing well here now. So if I curl this in the browser, I get my poem. If I do it by accession number, I get this other poem. If I do it by this thing's ID number, (13707). Is that right? Yes, I think. Whoa, wait a minute. What am I? That's strange. What in the world? Now I've got 424, 13707. 13707 is giving me, that's correct. Wait a minute, is that correct? Hold on, I'm losing my mind. All right, it starts off with the severed head. Okay, is 13707. Yes, the severed head, and that's the same 424. Whoa, that is so weird. It's a different, but they're both. What am I? I'm losing my mind. They're this. It's two different Oh, wait, that's why. Okay, okay. It looks like this didn't delete. I thought I did delete this, but let's try this. Oh, you know why? Duh. Okay, because I haven't deployed it. All right, so I'm using this. This is the production endpoint. Oh, okay. We would do localhost 3000. I don't know what I'm doing. I'm just messing around now, it feels like. There we go. Okay, localhost. And so now if I do, that was silly. All right, so let me just delete this because I made a mistake. All right. Okay, I believe it works. I think we're in business. And I think we should deploy it before it's too late. All right. Okay, so we're going to do a deploy. Oh, and you're looking at the browser. Well, I'll leave you on the browser for the moment while it deploys. Because while we have a few more minutes left here, I want to talk about what's next. Okay, so I think this thing works pretty well now. There's a few little bells and whistles I would change, and I'm going to do those things and like update the code on GitHub. But for the most part, I think it's working. I think we have a winner. So let's take a look at this architecture because here's what I want to talk about. What can we do with this thing, right? So basically, we created this service, and it generates poems. It stores them in a database. It sort of acts like a cache, so we can retrieve those poems if they exist. If not, we're going to use Bedrock to generate them. Uh, like lovely, it works just fine. But what are we going to do with this thing? So I have a couple ideas, and this is what's fun about this for me is that um, we can create several things with this because we basically have a little service here now. Let's create like a boundary group kind of thing to talk about it. Um, Container, that sounds good. All right. Not like Docker, but just a box. All right, so we have this thing now that is our service, right? So this is, for lack of a better word, this is our poem generation, poem service thingy. But what can we do with? So I have a couple ideas of what we're going to build with this thing. First of all, I think it would be fun to have some kind of a website um, to display them, right? That seems obvious. So we can make a website of some kind. And that website can basically do the exact same thing we've been doing. It can display the poems somehow. So we might have to add a little bit of code to do like a get all the poems, for example. Um, but yeah, that's it. It's just basically a simple website that displays them. But I'm also thinking like we should also come up with something a little bit more fun. Like I would like people to be able to sign up and get these in their inbox or something. Um, so that's interesting. How would we do that? Uh, yeah, I can think of a bunch of different ways we can do that. So what would it look like? So let me just think it through out loud while we're here. So first of all, we have some kind of sign up form on the website. So we're going to need to sort of store that. So we're going to have a different service, I think, to deal with signups or users, right? So let's draw that. Let's just use the same thing here. Whoops. All right, let's put it down here and we'll make it a little smaller. So we might have a whole separate like kind of thing to store users. So what would that look like? It's going to look kind of similar. It's going to have an API gateway. I think it's going to have a Lambda function. I'm pretty sure it's going to have a DynamoDB table. And that might be about it for now. And so let's say there's a sign up page on here. Whoa, whoa. Yeah, I don't want it to be this crazy arrow. Whatever, that's fine. So let's, what I'm missing like the panel over here. Okay, hold on. I know how to do this. Oh, it's like different now. Something has changed. Format? Yeah, there we go. Okay, so, all right, let's say we have a sign up page and yeah, that lets people use an API to sign up. And what are they going to sign up with? They're going to give us their email address, and maybe we'll ask some preferences like what's your time zone, so that we can send you email with one of these poems like once a day. Let's just use that as a starting point. So then we're also going to have some kind of like scheduler, right? Is that a thing? Yes, EventBridge scheduler. That sounds cool. So we're going to use EventBridge scheduler. So like, and because we're thinking about time zones, we have to run this like once an hour or something like that, depending on your time zone. So we're going to have to come up with some logic that basically figures out when we send you a poem. And then we have to figure out which poem to send you, right? So maybe it's the most recent one, or maybe we do a random one because we were talking about that last time. But the point here is we're going to do something with our work. So so this thing is going to generate like an email. Okay, so where's SES? Good old. I thought we have SES on here. Let's put email. Simple email service. There we go. Okay, so like on some schedule, we are going to probably run a Lambda function of some kind, or a step function maybe. We could do that. That might be fun. I don't know why. But anyways, we're going to write some code or write some process here, which is going to, what's it going to do? All right, let's just sketch it out here a little bit while we still have a minute. All right, so the Lambda function, or whatever the compute is we choose here, is going to somehow pick a poem. I don't know how yet. Maybe it's random. Maybe it's a new poem of the day. I don't really know yet. And then it's going to select users based on time zone. So it's basically going to look in this table, this users table, and it's going to say, if you're in this particular time zone, you're getting a poem right now, right? And then it's going to send it to them. So we'll have to figure out how to do that. These are some things I do not know how to do, so this is going to be fun. So send poem to users. And I think SES is probably the tool for this job, but I'll have to do a little bit of homework. And I think, so this part, yeah, I'm not entirely sure how to do this part, but we can definitely start with building like a simple website and letting you sign up. We'll figure that part out first. But we're out of time. So that was fun. We did a whole bunch of stuff and it actually worked. I can't believe it actually worked, but it worked. And it looks like it has deployed properly too. So I'm like I'm rather impressed. Okay. Yeah, there we go. Okay, so that's it for today. We are wrapping up. I'll be here again next week, I think. I'm pretty sure, hopefully. And we'll dig into making this thing actually do something useful. That'll be fun. Okay. All right. Goodbye, everyone. Have a good one. Take care.